What is up everyone, and welcome to our tutorial on objects and classes. In this topic we're going to basically put together everything that we've covered up until this point and build upon that with this new topic. We'll divide this section into two subtopics, the first being of course what are objects and classes. This will be a couple of slides explaining what this topic means to us and how we use objects and classes in Python. And then we'll turn to REPL.it and explore some examples of objects and classes in real Python code. Okay, so for starters, what are objects and classes? From a code standpoint, objects are entities with state and behavior. We implement the state of an object with a bunch of related variables that kind of describe characteristics or attributes of an object. Whereas we implement behavior through functions. These are used, generally speaking, to change the state by changing the values of the variables related to that object. So, take for example a player within a game. Some examples of variables a player might have would be things like health, damage, movement speed, etc. A collection of these variables would help to describe the state or the set of properties or attributes that this object has. For behavior, we might have functions that help the object to move around, attack, take damage, etc. These would be performing some sort of actions, typically that would modify the state of this object or the state of the overall program in some way. Classes, on the other hand, simply act as blueprints for objects. We use the classes themselves to define the variables and functions that an object should have. So if we think about the object as being the part of the code that contains and stores all of the properties in those variables and can perform actions through its functions, the class is simply a way of defining what kind of variables and attributes an object should have and exactly the implementation or how those functions should work for the object. Okay, so this may sound a little complex, but it's actually pretty simple because we'll be putting together everything that we've learned previously, so we're not really going to necessarily need to learn brand new topics here. So let's head on over to REPL.it and get started. In this section we'll have an introduction into classes and objects. In the next we'll get into a slightly different topic of inheritance. Okay, so as per usual, we are starting from fresh in main.py. I have put all the other stuff. I think functions was the last topic with regards to parameters and return values. I've put that in our archive.py file for reference for later. Okay, so the first thing that we'll need to do when building classes and objects is define the class. We cannot have the object with state and behavior if we don't have the blueprint that defines what the object looks like. So I think we'll actually just launch right into our example, and what we're going to do is again model some sort of a game. Within a game, we'll likely have various objects that have properties such as positions, or maybe they'll be able to move, maybe they'll have a name, stuff like this. It's going to be a pretty generic game object. So what we'll do is we'll start a class with the class keyword, and then we give this a name. So in this case, I'm going to call this game object, okay? And then again, the semicolon, or rather the regular colon, and then the indentation describes the items that belong to this class. So for example, this would belong to the class, whereas this would not because of the indentation differences there. Also note that we're using camel case now with a capital at the beginning. This is typical naming convention for classes, as we're actually defining a new type of variable by creating a class. Okay, so every time we create a class, we're creating a brand new data type for our program to use. And typically, this data type is a collection of other variables that describe its overall state. Okay, so let's see what kind of things a game object might have. Again, we're just going to add in a few attributes. We're not going to model a full game object. We'll actually save that for the game itself. And we might go with something like a name of an object. An object might also have an X and a Y position. So in a lot of languages, you'll see something like the variables being declared like this, up at the top. So we'd have like an X position, for example, we'd have a Y position, so on and so forth. That's actually not necessary in Python. What we can do is actually describe all of these properties in what's called an initializer function. An initializer function is essentially a way to define what properties an object should have in Python, and also to set the initial value of those objects, or rather of those variables that belong to the object. So just bear with me here. I'm going to just write out the definition and then I'll explain what's going on. So we use special syntax for the initializer. We do def with 2 underscores and then an init and then 2 more underscores like so. We have to put in the self parameter. Again, I'll explain what that means in a minute here. And we want to pass in values for some of the variables that we'll want to set when we create an object. So for example, we'll want a name. Okay, we'll want an X position. I'm just going to shorten that to X pos, and maybe we'll want a Y position as well. Okay, so we use this initializer and these parameters or these values that are passed in to set the initial value of this object. So what we would do is do self.name is equal to the name value that we pass in. Self.xpos is equal to the xpos value that we pass in. And then we'll do self.ypos is equal to whatever Y position value that we passed in. Okay, so I know I just hit you with a lot. There's a lot of strange syntax. There's this weird keyword self. We're dealing with, again, some strange definition here. So let's break this down bit by bit. Essentially, what we're doing when we are creating this initializer function is saying that every time we create a game object, okay, we want to set these properties of the game object. So we want every game object to have a name. Okay, and we're just going to set it to whatever value we pass in. We want game objects to also have X and Y positions, and so again, we're just going to have to pass in values when we create a game object for the name X and Y pos, and then we would just set those values equal in the self.variable name is equal to whatever value here. We use this self keyword in pretty much all of the functions and the variables when we're accessing them from within functions of an object here. So what this means is that we're saying that every game object will have a variable called name, or will have a property called name. And by saying self.name, we're referring to the name variable that belongs to this specific object. Really, this is a good way to differentiate between the parameters that we're passing in and the values of the variables that belong to this game object. The initializer essentially works like any other function would. When we create a game object, we call upon the function, except that we don't use the init syntax. We actually use something slightly different. I'll show you in a minute. But we still need to pass in some values here, and then we just run that code to create an object. Now, before we implement any kind of behavior, I think it's important to demonstrate this part here in action. So hopefully you guys can understand a little bit better exactly what's going on. So this is a class for a game object. This is basically defining the blueprint. We know that every game object we create will have a name, an X position, and a Y position, and we need to set all 3 of them when we create a new one. So to create a new game object, we could do something like this. I'm just going to create a variable called game object, and rather than doing game object.init, which I guess we could actually do, there's nothing technically wrong with that, the more typical naming convention is to do something like this. Okay, game object as the type of the variable, and then we're just going to pass in some values here. So I'm just going to call this enemy. Maybe it'll start with an X position of 1 and a Y position of 2. Essentially, what we're doing here is we're creating a variable called game object, and rather than assigning it the type of, let's say, an integer or a float or a string or a boolean, we're actually assigning it the type of the game object, which itself has some variables that are a string and probably some integers here. So this game object stored in here has the value of name equal to enemy, X position equal to 1, and Y position equal to 2, because we are essentially passing those in as the name, X and Y position, and setting the name that belongs to this game object equal to that value, the X position which belongs to this equal to this, and the Y position to 2. We can then use this variable, the game object variable, and the dot syntax to access, as you can see, the name, X and Y position. We can either fetch these, or we can set these. For example, if we did gameObject.name is equal to enemy1, and then we print out the new value, gameObject.name, okay? You'll see that if we run this code, we start with the game object, the name, the value that belongs in the name variable equal to enemy, and then we just change the name that belongs to this game object to enemy1, and we're now printing out the new value here. Alright, so we're actually going to stop here. We will expand more upon this in the next section, where we'll be introducing some functions as well. So stay tuned for that. Thanks for watching, and see you guys in part 2. What's up everyone, welcome to part 2 of our Objects and Classes tutorial. In the previous section we started building our GameObject class, and we also created a GameObject object. So now we're going to expand upon that, and we'll also add in some functionality to this class. So let's head over to the code and get started. Alright, so hopefully you guys could follow along, but let's just kind of summarize what we went over last time, because I know we threw a lot at you all at once. So as of right now, we have a GameObject class, okay, and we have only the Initializer function, which is basically setting up 3 variables that describe 3 different properties that every game object will have. So anytime we create a game object, we need to use this initializer function to pass in a name, x position, and a y position, and that means that every game object will have those values set here. Basically, anytime we want to set a value that belongs to an object, we use the self dot and then the attribute name, and then we can assign the value, which we'll actually see a bit later on in this tutorial. Down here, we created a new game object using our initializer, and we can pass in a value for the name, value for the x position, and y position. So basically this says that this variable called GameObject is of this type, and it has 3 properties: name, x, and y position. We saw that we could access the name using the variable name dot and then the name value. Similarly, I guess we can also access the x position and y position like this. We can do GameObject.x position and the GameObject.y position as well. So these essentially are all values that belong to this GameObject variable. So we can fetch them simply by doing GameObject dot and then the variable name. We can also set them by doing the GameObject dot and then variable name is equal to something else. We can't set something that doesn't exist, however. For example, I can say GameObject dot damage is equal to something else, because damage is not really a property that exists in this specific object yet. At least for now, we don't want to be doing this. It's a bit beyond the scope of what we're trying to achieve here. Okay, so we can do basically the same thing we're doing here, but with functions. For example, if I create a function within my game object outside of the initializer, I can call upon that function to execute some code. So for example, let's say I want a simple movement function. I'm going to start my def here to create a function. I'm going to call this move, okay? And I'm going to add in a parameter by x amount, okay? We could also do by y amount, but more on that a bit later. Now we actually need another parameter, and that is going to be self. So the reason we need to add in self here is that this says that this function basically belongs to every instance of a game object, so that every time we create a game object variable, we can call upon this move function on that object. Okay, so let's add an implementation to move. Essentially what we're just going to be doing, and you know what, actually I guess we'll add in a by y amount as well. Kind of makes sense. So what we'll do here is we'll say self.x position plus equals by x amount, and then we'll do the same with the y position. Alright, so this works just like any other function. We're passing in a value for x, passing in a value for y, and then we're just changing up the x and y positions by that amount. Hopefully that pass is fairly straightforward based on the tutorials that we covered on function parameters. So by using self dot, we're again accessing the x position and y position variables that belong to an instance of this game object. Okay, if I had just said something like x position equals, by x amount, this is actually not referring to the x position that belongs to this game object. To get that, we have to do self dot and then the x position. Okay, otherwise that just creates another variable for use within the function only. Alright, so you know what, we'll leave those up, may as well. What we're going to do here is use our GameObject instance and the move function to change the x and the y positions. So as of right now, if we run the code, we know that our GameObject x position is 1 and the y position is 2. What we want to do is take our game object and we want to call upon the move function. Because we've implemented it and it's a function that belongs to every instance of a game object, each variable of type game object is considered an instance. We're going to do gameObject.move. We're going to pass in a new value for our x amount. Let's do maybe 5 and 10 for the y amount. Note that we actually don't need to pass in any parameter for self. Okay, the self parameter is just a necessary component that dictates that this function belongs to every instance of game objects. Okay, so once we add it in, we can basically ignore it. This is just saying that if we want to access properties such as x and y position, we can use this self here to do so. Okay, so this game object is going to move the x amount by 5 and the y amount by 10. So we know that at this point in time it's 1 and 2. So what do you think the new values of this game object's x and y position will be? Well, let's go ahead and print that to find out. As you can see, the x position has increased by 5 and the y position has increased by 10. Okay, this makes sense. Again, we're calling upon the move function on this specific game object. Okay, that means that it's going to go into here. It's going to pass in 5 and 10 here and here. It's going to increase its x position by 5 and its y position by 10. Okay, so that way, when we access the game object's x and y positions again, we know that they have changed. So we can do this with pretty much any function that we want. Mostly, generally speaking, we use functions to modify the properties or the state of an object in some way. But of course, we don't just have to do that. Sometimes we can pass in other objects and modify those. And there's lots of other things that we can do here. Okay, so one other thing I want to point out is that we can create as many different game objects as we want. For example, let's say I wanted to create an other game object. Okay, there's going to be another game object. I'm going to call this one maybe player. Maybe its x position is 2 and its y position is 0. Okay. Now if I access the properties of other game objects, you will probably see that these values are different from our regular game object values. So I'm just going to copy and paste these over. Okay, and I'm just going to print out my other game object's name, x and y positions. So you can see that the values are different from my original game object. And that's because this is a brand new variable and a brand new instance of a game object. So just like we'd create a new integer or a new string, here we're just creating a new game object. So already you can see that this is extremely useful for modeling what we want to be kind of like a real world entity within, in this case, a game. Okay, and we want to attach multiple values to this object rather than having to cart around a name, x and y positions separately. Just like the original game object, we can call upon the move for other game objects as well. Okay, so we can move by a certain amount also. Now, the final thing that I want to point out here, and this is kind of a weird concept, is that objects that we create, these custom classes and objects, these are reference types versus value types. So what do I mean by that? Well, when we create, let's say, something like an integer, or a string, or a boolean, those are value types, which means that when we assign one equal to another and change one of them, the other doesn't change. So for example, let's say I have one int and I set this equal to 5, and then I have another int and set this equal to one int. Okay, we know that both of them are equal to 5. So if I print one int and I print another int, you will see that they're both equal to 5 at this point in time because we're taking the value stored here and we're copying it into here. If I then change one of these values, so I say another int is equal to 10, and then I print them both out, you'll see that another int has changed, but one int is still equal to 5. And this is again because values are copied in this case. Well, with objects, we actually are not copying. We're referring to the same object when we do something like this here. So if I take my other game object, which we know has the values player, 2, and 0, and I set this equal to my game object, okay, then I actually print out the other game object.name. Okay, I'll go ahead and run this. You'll now see that this says enemy1 instead of player, because this variable now refers to the same object as game object. Also, if I reassign the name of either one of these, so let's say gameObject.name is equal to new name, okay, and I print out the game object, the other game object's name, and the game object's name, you'll see that they will both be equal to the same value now. So I'll go ahead and run this. Just pause this for a sec. You'll see that they are both equal to new name, again because they're both referring to the same object now. Alright, so we'll be diving deeper into exactly what's going on here and exploring another concept in the next section. So stay tuned for that. Thanks for watching and see you guys in that next one. What's up everyone? Welcome to the third part of our Objects and Classes tutorials. Here we're going to kind of go over again what we meant by reference versus value types so that you really understand this concept, and then we're going to move to a new one of inheritance. Okay, so let's head on over right to the code and get started. Okay, so before we move on to inheritance, I just want to make sure that we all understand this concept of value versus reference. So, again, when we created these integers and assigned one equal to the other, what this is doing is actually copying the value. And the same will be true for integers, floats, booleans, and strings. Okay, so these are fairly basic data types. That means that, again, we assign one equal to the other. We're just copying whatever value is there at that time into that other variable, so that if we modify one, we don't modify the other. And we saw exactly that with this. When we changed another int to 10, one int did not change, but another int did. However, when we're dealing with objects, as soon as we assign one object to another one, we actually create a reference between the two. So now, before, other game object was its own thing. It had the value of player, for name, its x position was 2, and its y position was 0. However, on this line of code, we actually said other game object is no longer its own thing. It's actually referring to game object. Okay, so it's the same operation as before, but because we're dealing with objects, these are reference types, so now we're saying that this refers to the same object here, which means that they are essentially the same thing now. Other game object is no longer player 2 and 0, it's whatever value game object has, so enemy 1, 1 and 2, okay, and forevermore it will be. So because these two refer to the same object now, anytime we change anything in one of them, it changes in both of them. Okay, so that's something that we definitely have to be aware of when we're dealing with objects, because if we're not aware of that, then we'll end up changing a bunch of stuff potentially in our code and wondering why all of a sudden all of our values are changing all over the place. So hopefully you're comfortable with that. Definitely once you practice a little bit more, so practice mimicking this kind of scenario with strings, ints, floats, and booleans, and then practice mimicking this scenario. Once you practice a few times, you should get it down and you'll be able to understand what's going on. Otherwise, what I'm going to do is actually clear pretty much all of this code up to this guy here. I actually want to keep my game object class, and I want to keep this game object. Don't worry, I've stuck everything else in archive.py, so we have an archive of what we wrote previously. So let's get to the topic of inheritance. When we're dealing with inheritance, essentially what we're doing is we're creating a brand new class that contains all of this stuff, but can then define its own additional attributes and functions. So in that scenario, we have this class, which will be the superclass, and then the new one, which will be called a subclass. Now I know that those words don't really mean much without the demonstration, so let's actually launch right into creating another class that is going to have all of the same stuff as this, but we're going to use inheritance to save ourselves a bit of trouble. What we're going to do is we're going to create a class called enemy. So this will be like a game object in that it needs a name, x position, y position, and it needs to be able to move, but we want it to have additional attributes and additional functions. Because we want it to basically inherit everything that this game object has, including this and this, we can do this by opening up the parentheses and saying that it inherits from game object. So at this point in time, after having created this, we have an enemy. We've inherited from game object, so any enemy we create will have this initializer, it will have this move function, and it will have a name, x position, and y position, which makes it the subclass and this the superclass. Okay, now we want to define additional stuff. Maybe our enemy has a health attribute. So we want to create a slightly different initializer because we want to be able to pass in health as well. So we're going to follow the same syntax, same self, name, x position, y position, but we also want health. Okay, because we want to, again, not repeat this code, what we're actually going to do is say super dot init, oops, not class, self.init like this, and then we're going to pass the name, x position, y position, and then we're going to also set the health. So we'll say self.health is equal to health. All right, now I know, again, I threw a lot at you all at once, so let's go over what we're doing here. So just like before, we're creating our initializer, and we're saying that we need a name, x, and y position passed in every time we create an enemy. However, we want an additional attribute called health, so we added that to the list of parameters. Now, rather than saying self.name equals name, x position, y position, etc., we're actually going to use the superclasses initializer to set these variables up. So because the superclass is a game object, we're inheriting everything from here. We get access to all of the functions, all of the variables that our game object has. So by calling upon super with the parentheses, we're saying we want the superclass's implementation of this, which is essentially this code here. So rather than having to repeat that code, we can just say super.init, pass in the name, x, and y position, and the code will find this initializer and use this functionality. We then also want to set up health, so we're going to do self.health just like we did set up the other attributes. So you might be asking why we're doing this. Well, we do this, generally speaking, to save ourselves having to repeat code multiple times. This is, again, bad practice if we're repeating code. It makes the code much harder to maintain. If you need to change something, you need to change it in multiple spots, which is not what we want. Also, it just helps us to avoid having to repeat multiple lines of code, so it saves us the strain of having to write extra code. So to demonstrate this, we already have a game object, which is of type game object. We're going to create I'm actually just going to change this to game object. Okay, I'm going to create an enemy now, which is going to be of type enemy. Okay, so just like before, I can use the initializer to set things up. So it needs a name. So I'm just going to call this enemy. Okay, it needs an x position, maybe we'll do 5, y position of 10, and maybe we'll have a health value of 100, because again, it needs health as well. Now the cool thing is that I can do gameObjects.name, okay, and maybe I want to print this out, okay, and I can also print out my enemy's name. Okay, so I haven't explicitly told anything that my enemy will have an attribute called name. Just like an enemy will also have an x position, a y position, and some health. And it also has access to the move function, as you saw there. But because we are inheriting from GameObject, the compiler knows that, okay, this enemy and every enemy object will have the same stuff that a GameObject has. However, because this is the subclass and this is a superclass, GameObject doesn't necessarily have access to everything that an enemy does. For example, I can't do GameObjects.health. Okay, that doesn't exist in my game object. That's something that belongs to my enemy only. Similarly, I can define functions within my subclass. Perhaps I want something that will help the enemy take damage. Maybe we'll call something like take damage. Again, I need to pass in self. I need to because it's going to be a function that belongs to an enemy instance. And I'm going to take in a damage amount. And I'm going to just say self.health minus equals amount. Okay. Because I've defined this function in the subclass, my GameObject superclass has no knowledge of this take damage function, and so I can do this enemy.takeDamage. Maybe I want them to take 20 damage, but I'm not going to do the GameObjects.takeDamage, okay, because it just doesn't have access to this function. So perhaps I can do this, and then I want to print out my enemy.health. Okay, if I go to run all this code, because we haven't run it yet, you can see that my game object's name is GameObject, my enemy's name is enemy, and after calling upon the enemy.takeDamage, my health is now equal to 80, because I've taken 100 and subtracted 20 from it. Okay, so that is the basics of inheritance. Again, it's extremely useful for saving us from repeating old code. Again, that's bad practice, and also it's just makes the code harder to maintain. Also, it allows us to model complex relationships between objects. For example, it makes sense that an enemy would have everything that a generic game object would have, but not necessarily vice versa. For example, not every game object, maybe a rock or a tree, necessarily would have to have health. Alright, so I know this can be a confusing topic, but don't worry, this will become so much clearer once we move to the game development section, as we're going to have to model everything as classes and objects anyway. So that actually concludes our language basics section. For this one especially, definitely try to model another scenario like this where you have a superclass and a subclass. Try to create an initializer with some setup properties like this. Try to create some functions and maybe try to make each one slightly different so that you can see what has access to what and what doesn't. And when you're ready to move on, we'll move to the game development portion where we'll be applying all of the stuff that we learned in language basics over the next couple of hours or so. Okay, so thanks for watching and we'll see you guys in the next one.